Hello children, a warm welcome to you all. In the previous session, we learned about the poles of magnet and how we can find directions with magnets. Now in this session, we are going to learn how to make magnets and compass on your own and about magnetic induction from the lesson Fun with Magnets from class 6 science. Learning outcomes. At the end of this session, you will be able to understand about making magnets on your own, making a magnetic compass on your own, magnetic induction, cautions for handling magnets, keywords, magnet, the substances having the property of attracting ion, pole, the ends of the magnet are known as the poles of the magnet, magnetic compass, a device which is used to show direction, magnetic induction, the process by which a magnetic substance acquires magnetic properties temporarily due to the presence of a magnet close to it, magnetizing, the process that makes a substance magnetic. Before we start, let us look at the concept map of this session. There are several methods of making magnets. Let us learn the simplest one. Take a rectangular piece of iron. Place it on the table. Now, take a bar magnet and place one of its poles near one edge of the iron bar. Without lifting the bar magnet, move it along the length of the iron bar till you reach the other end. Now, lift the magnet and bring the pole, the same pole you started with, to the same point of the iron bar from which you began. Move the magnet again along the iron bar in the same direction as you did before. Repeat this process about 30 to 40 times. Remember that the pole of the magnet and the direction of its movement should not change. Now, remove the bar magnet and bring some iron fillings or alpins close to the iron bar. You will notice that the iron bar attracts the iron fillings or alpins. Thus, you succeeded in making your magnet by magnetizing the iron bar. You can also use an iron nail, needle or blade to convert them into a magnet. You know now how to make a magnet. You can also make a compass. For this, Magnetize an iron needle using a bar magnet. Now, insert the magnetized needle through a small piece of cork or foam. Let the cork float in water in a bowl or a tub. Make sure that the needle does not touch the water. Make a note of the direction in which the needle points when the cork is floating. Rotate the cork with the needle fixed in it in different directions. Note the direction in which the needle points when the cork begins to float again without rotating. The needle always points in the north-south direction when the cork stops rotating. Thus, it acts as a magnetic compass. To understand the concept of magnetic induction, let us do an activity. Take a safety pin and bring it close to one pole of a bar magnet and see how it gets attached to the magnet. Now, bring an awl pin and touch it to the safety pin. The awl pin gets attracted to the safety pin. We notice that the safety pin acts as a magnet when it is in contact with another magnet. Magnetic property is induced in the safety pin due to the bar magnet. Magnetic property possessed by a magnetic substance due to the presence of a magnet near it is called magnetic induction. If the safety pin is not in contact with the bar magnet, can it attract the awl pin? What happens if we place the bar magnet very close to the safety pin without them actually touching each other? Let us find out. Take a bar magnet in one hand and a safety pin in the other hand. Hold them in such a way that they are close to each other but not in contact. Ask your friend to bring an awl pin and touch the safety pin. You will notice that the awl pin will stick to the safety pin. This shows that due to magnetic induction, safety pin acts as a magnet. Let us know about the few cautions for handling magnets. Magnets lose their properties if they are heated, hammered, or dropped from some height. Also, magnets become weak if they are not stored properly. To keep them safe, bar magnets should be kept in pairs with their unlike poles on the same side. They must be separated by a piece of wood, while two pieces of soft iron should be placed across their ends. For a horseshoe magnet, one should keep a piece of iron across the poles. Keep magnets away from cassettes, mobiles, television, music systems, compact discs, and the computer. Points to remember. During magnetization, the pole of the magnet and the direction of its movement should not change. A freely suspended magnet always aligns in the north-south direction. Magnetic property possessed by a magnetic substance due to the presence of a magnet near to it is called magnetic induction. Magnets lose their properties if they are heated, hammered, or dropped from some height. Magnets become weak if they are not stored properly. Thank you.